I think we are live. Hi everyone, how's everything going on? I hope you all are super excited for the session. So today one is like super interesting. But before going into that, what we are going to cover, let's see what exactly we are planning to do. So here's basically the curriculum for the Ethereum Buildcamp. As you all know, it's basically a week long program that we have decided to do with Ethereum Foundation, specifically with the team to introduce Ethereum to more and more folks where they can learn around the things, build together, and eventually make most out of it. So over here, like we already have a couple of sections, but exactly Ethereum is about how you can write your first smart contract. And yesterday itself, we learned about modern Ethereum stack in the form of Lego, which is something really interesting session that I really enjoyed. And then today we are gonna covering more around how you can build your first app. So as you know, this is basically our AI era, and over here in this particular timing, you can build anything instead just by discussing it with AI in form of English language, and it will do the coding work for you. So which is like pretty interesting. So Viraj will be covering all the doubt for you folks. Over to you, Viraj.
Hey, hi guys. Nice to be here. Thanks, Bhavna, for the for introducing the session. And yeah, excited to be here. And today, yeah. So just a bit of an intro about myself. So I've been in the blockchain space for about like 7 years now. Just like building different DeFi protocols, doing some auditing, doing some open source work, and then just now, incorporating AI in my workflows and things like that. So today, basically, I'm just gonna show you guys about how you guys can basically just like using AI skills and your own prior knowledge. You can just easily create a dApp and start like playing with it pretty soon. So I'm just gonna share my screen. I think my screen's already shared. Yeah. So I'm just gonna share my screen, and then basically today I'm just gonna walk you over through a demo DeFi app, which is gonna be like a demo ERC4626 vault, where you can build that vault and then just connect that with the front end, pretty much. And then you can just like play around with it just to get yourself an idea that how building your first app would look like. So we'll first, we'll just take it step by step. So we'll first start with the smart contracts, uh, where, as you can see, this is more of a Foundry setup, where you can easily follow Foundry dots and just like initialize a initial like a setup base for your Foundry project. So I did the same. And I used my agent to basically help me with the setup and everything. Right. And then basically, yeah, you just like set Foundry up, and then you start working on your first smart contract. And today I'm going to be demoing this, the demo vault, which is a ERC4626 vault, where the idea is that people can deposit funds, and those funds can grow in yield depending on the yield strategy that the vault is using. So think of it as interest on your deposits. Like, for example, if you make a deposit in a bank, or and you get interest on top of your deposit, right? So it's similar to that, but probably more cool, right? Yeah. So we start off by inheriting the ERC4626 contract from the Open Zeppelin contract repo, which is the base layer for you to just like build on top of a base ERC4626 version. Because I think Open Zeppelin has standardized these ERCs, right? So which gives you a very good head start. Instead of you building things out of your own, you can use things like Open Zeppelin, or even Solidity, or these repos where you have a standardized version of smart contracts, which you can use and inherit and then build on top of those base contracts and add your own custom functionality. So we basically start off by inheriting the ERC4626 smart contract, and we inherit the ownable contract of the ownable ERC Open Zeppelin contract, which allows you to do perform certain actions only by the owner of the contract, pretty much. And then we define a couple of variables around yield rate per second, and then when was the last yield accrued, right? And then we pass our demo token, which can be any ERC20 token. So right now I've just taken this mod token, that I'm gonna be using to showcase this demo, pretty much. So you can like use any, if you're like building on mainnet, you can have like USDC, you can launch your vault with USDC or any other asset, right? Right now it's just like this is a mod asset. And then we just like inherit that. We define the address in the constructor when we deploy the contract, so this code gets executed. Then we have the last yield accrual timestamp set as the current block timestamp. Then we have this function which basically gives us the pending yield, where we basically just check that when was how much yield has accrued since we last checked, right? And then we get that amount, pretty much. We get this is a total assets function, which is basically part of the ERC4626 standard. So, and we have to override it because we are inheriting that contract. And this basically shows that how much what's the total amount of assets held in the vault, and this includes the yield as well, right? And then we have this custom function to accrue yield. Given that this is a demo and just like showcasing you guys how everything works, so right now we are basically just simulating yield by minting some tokens, with time to this vault. But in the real life scenario, this won't happen. In a real life scenario, you will be depositing the underlying funds to an external protocol, or you will be supplying liquidity from outside to this protocol itself to accrue yield, right? So, but here this is just again for demo purposes, that we can showcase that we are getting yield on top of our deposits. After that, we have these parent contract functions, which is called deposit right now. So we override this, and then we are just basically making one change, that we are calling this accrue yield function on top of the main the base deposit call. And this is again just to make sure that on every deposit we keep accruing yield, right? And similarly, the same case goes for withdraw functions, where we override them, and then we again call accrue yield on top of it. After that, we have a couple of admin functions, which I'll get into. So one is just like the yield rate function that we saw, like the variable that we saw. So this is just allowing the owner to set the rate. And this is the only owner here comes, the only owner modifier here comes from the inherited ownable contract that I showed you guys up before. And then this is more of a security check, security prevention, security mechanism around ERC4626 vaults. Because what happens is, when you are building these DeFi protocols, right, there can be a lot of security pitfalls that you need to avoid. So defining a decimal offset is one of them. Basically, this is preventing the first time depositor attack. So the idea is that if let's say if this was not there, then a malicious actor can basically front run and take advantage of the whole yield, or the whole like deposited assets, if they can front run the first depositor who deposits in the vault by depositing a very small amount, and then they can cause an issue in the whole functioning of the vault, right? And we don't want that. So we use this decimal offset to basically make sure that that attack mathematically cannot happen. You can like read more about it if you like go deep into ERC4626 specifications, or you deep dive into the security pitfalls around it, you can obviously like read more about this, right? So but for this purposes, for the purposes of this call, I'm not going to dive deep into that. Yeah, so we have got our contracts out of the way, and I already told you about the token contract. Then we have this foundry script that interestingly enough, if you've like worked with hard hat before, then it seems a big change, because here you can write your script in Solidity itself. So you have this script which is basically used to deploy the contract on a test net or mainnet, on whatever network, pretty much, based on whatever network parameters that you configure in your deployment command, right? uh, so this is basically just using the foundry script contracts, and then inheriting from that, and then just making sure that both the token and the vault contracts are deployed, and then we are setting the token minter as the vault, and then we are setting the yield rate as one demo token per second. And then and then we just like logging out all the both the addresses pretty much. So with foundry you can, your development speed, even if let's say in a hypothetical world there was no AI yet, your development speed still increases by a lot, because now you can handle all of the contract related things through just Solidity, right? And then we have a basic level of tests, where and which is all, I obviously always recommend this whenever you are doing any sort of building any sort of dApp. Always once to follow a test driven approach, where you write your tests in parallel to your contract, because that helps you to figure out the key invariants, or things that should be intentional in terms of the protocol, in terms of the contract, and it helps you to catch out bugs early. So always you want to keep your test coverage up, close to either 100% or very close to it. And these are like some basic level basic tests around deposits, around making sure there's yield, around withdrawals. And with foundry now you can go, if you go through foundry documentation, you can write fuzzed and fuzz tests as well, which include the stateless fuzzing tests, and then invariant tests, which is like pretty much a stateful fuzzing. And now I saw that they recently introduced symbolic testing as well. So I think all of those things are pretty helpful and pretty recommended security wise, because essentially we are dealing with immutable code, right? So always make sure that your test coverage and your test suite is up to date with integration tests, unit tests, fuzz tests, and everything, things like that. And then you obviously, like in a real scenario, then you proceed with your audits, making sure your documentation and everything is complete. So yeah, in terms of the contract, I think this is pretty much it, like the contract section. And now we're going to dive into the front end section, which is sort of easier to understand, because that is more of a thing, like that's more of a web 2 component, where we have these web 3 libraries like ethers.js and all, where you can integrate with contracts, which is like sort of obviously different. So yeah, here we pretty much have our app level code, where we we are using the viem library. You can use vim as well now. So there are so instead of like ethers, you can use a viem and vim. So you get like the same kind of features in that sense. And now these are like new libraries that have come up, so you can use these, and we're using them. So now what we're doing is we are basically importing the addresses and the ABIs for the contracts. An ABI is just basically an interface, like an interface structure of the contract. So the when you make call, when you make these interaction calls with the contract, then these libraries like ethers.js or the viem library knows how many arguments, what type of arguments are needed, and things like that, right? And then we are just like doing some stuff around, we're just defining some constants around the decimals, and we have some helper functions around formatting. Then we have these ABIs, like I said, because we also have to display, render some information on the UI. So we are basically calling this use read contract function to call the view methods of our contract to basically just fetch the information on chain in our contract, and then render it on the UI. So this is pretty much that. We're doing all of these things, and then we have the write section displayed, where we basically spend some gas and execute a transaction on the blockchain, where the first step is that we have this use write contract function to fetch these variables, and then we again, like I said, constitute the input parameters that we want. And with Ethereum, for example, you always, whenever you want to do a smart contract interaction that involves amounts, especially deposit amounts, you want to use those deposit amounts in way, because in the way format, because otherwise you can run into like issues around your decimal handling and things like that on the UI, right? And you don't want that. Uh, this is again pretty much this section is just checking that if the wallet is connected. Then we just display render this information on the UI. After that, we again just have some we're rendering some data that we read earlier using the use read contract function above here. So we just right now rendering those that information on the UI. So this is like pretty basic. Then we have a faucet as well that you can use basically once per minute and things like that, just to get yourself some tokens for testing and things like that, but that's not relevant. Then we have the deposit function here, which is the main important bit, where you can deposit your demo tokens to the vault, and then you get this S demo share token, which is basically representing your share price, which is like part of the 4626 standard pretty much. Then and this is a two-step process, where we first have the approval process. As you know, ERC20s, you have an approval process. So we're going to be firing two transactions pretty much. One is going to be the approval transaction, and then the other, the deposit transaction. And that's pretty much the same, that we check first that if the asset needs approval, then we first display the approve button, or otherwise we display the deposit button. And then we have similarly we have a withdrawal button, and then we display that on the UI. So, and that's pretty much it. And then we have this redeem button as well, which is a similar operation to what withdrawal is. Right, and then we define our APIs and our addresses here. So right now they're hard coded, but you can basically replace them or use your agent to basically set your front end setup up whenever you are done with your contract deployment. Right, and then this is the API that I was talking about, that we'll have to use this API to make smart contract calls, as part of the VADME library. And then we just define the API here. We have our styling in the CSS file, of course. Then we have the main file, where we just basically mentioning all different components and providers here. And then we have the VADME library as well, where we define the our RPC and our host server and the RPC and things like that, which is again varies if you're testing on Sepolia or other networks. So you need to update the configuration here. And then that is pretty much it in terms of just initializing everything. So you can check this repo out if you guys want. I can probably drop the link in the chat, and then pretty much the idea is, I can probably drop it right now. Let me just check. Yeah, so I can drop the link here, and then you guys can check it out. So now I'm just gonna run through the README bit and everything, which is gonna give you guys some idea around how things are working. So this is what the demo, the UI right now looks like. It's pretty basic, just to showcase you guys how everything works in DeFi, and how a dApp works overall, end to end. These are all the features that I talked about. Deposits, withdrawals, faucet stuff, the faucet bit. and then you have, this is the structure, this is how the whole architecture of the app looks like. uh, and then we pretty much have uh, the a description of all these sections, pretty much how the DeFi, the ERC 4626 vault works, like the math of how it works. So it's pretty basic. Uh, this is the decimal offset bit that I talked about, which prevents you with the first depositor share price inflation attack that I spoke about. And then and then this is just instructions for you to basically run the demo and deploy the contracts on Anvil, which is the local blockchain that Foundry provides you with, which is pretty handy if you want to test things out pretty quick. And then it's pretty much very simple. And then I think also I'm gonna dive into another section which is around the AI involvement in all of this. So as obviously I think you guys probably have seen that we are living in the agentic era, right? And and now you have AI, in your set of like tools in your armory, right? And you have to make sure that you use it in the right way, because it's expensive with burning tokens and things like that that you probably already know about. So I think there are these resources around building Ethereum dApps, which efficiently and making sure your prompting and everything is up to date, correct, so you're not like deviating from what your original idea was. So this ETH skills was developed by Austin Griffith from Bill Yale from Ethereum Foundation. So he and his agent like worked on these. He worked on these ETH skills that a lot of people have been using. I've used them as well. It's pretty handy, pretty good. And while he was like training his agent, so and you can use the same resource for building your dApps, where basically you have these different skill sets in terms of doing different operations, in terms of building different types of things, or in terms of debugging or whatnot, right? And you can use these skills provided to your agent, and then you can see the whole app unfold right in front of you. And then you can do, you obviously can do customizations on top of it, add more features or things like that, or sort of sort of, for example, scan your smart contracts for security issues, or help you with deploying your app on Vercel, or setting up your backend on Railway or things like that. So and also like just playing around with external contracts, or just like doing all sorts of things. So I think it's important to keep learning and keep exploring in terms of how efficiently and how secure your dApp or app can be, right? In the sense of in terms of like the Ethereum ecosystem, because or in terms of the like the blockchain ecosystem, because I think the most important bit to realize here is that we in this space we work with immutable code, unless of course there's upgradability involved, but more or less it is immutable code, right? And it handles money a lot of the times, right? Like DeFi is the number one use case of blockchain as of now. And we always want to make sure that whatever stuff that we're shipping out is secure, is reliable, is efficient. And as you and I'm also like telling this based on whatever we have seen over the past few years in terms of on-chain exploits and all, and that is not ideal for anyone. So I just wanted to end the session by this. And yeah, hope you guys had a nice time. I'm reachable on Twitter or Telegram. You can definitely check it. If you wanna, you can reach out if you want to chat. Viraz 04 is my handle on both on Twitter and Telegram. So happy to have a chat if you guys need any guidance or any help around any stuff that you're building in. And yeah, hope everyone has a nice day, and thanks again for the opportunity. Yeah, Bhavna, I think you muted if you.
Yeah, thank you, Viraj. Yeah, thank you, Viraj, for covering it out. Actually, I was also thinking to covering around it. Still glad you covered like when I was learning around Ethereum. So no
Oh,
one
good to
told
know.
me
Yeah.
about that particular project. And it's gonna really help me. So
Yeah.
definitely,
Thanks a lot.
that's a really good project that you should read.
Thanks a lot. Yeah.
Yeah, have a good day ahead, guys.
Yep. Bye, guys.